day, that accounts for about 9 questions on your Math GED test. The formula sheet shows you how to measure based on the shape that you're provided and the type of measurement they want you to get. So like an area measurement and the shapes provided there, you can use that as a reference for the area formulas. Like area of a square is taking one of the sides and squaring it or timesing it by itself. Vast majority of the formula sheet itself are geometry formulas, as well as information about data calculations. And then underneath the algebra section, there is a formula called Pythagorean theorem that's kind of hidden down there that is used in a very specific scenario for geometry questions where you have a right triangle, meaning a triangle with a right angle in it, where 2 of the side measurements are provided and the third side is missing. A card is pulled from a fair deck of 52 cards. What is the probability that it is a heart? Okay, this is our first question from the section called Mostly Geometry. So this is a good opportunity to point out that this section doesn't even include all geometry questions. As we can see here, you're going to also see some probability questions in this section and some data analysis questions where you may have to calculate mean, median, mode, or analyze something like a line graph. In this question, it's asking us about probability. And with probability, we want to build a fraction. In fact, we can see all the answer choices here are fractions. That's helpful as a reminder. So for probability, build a fraction where the bottom number of the fraction represents the total number of outcomes which are possible. In this scenario, they tell us that we're dealing with a deck of cards that has 52 cards in it. So that number 52 is going to go on the bottom of the fraction. On the top of the fraction, we're going to be listing the possible outcomes that we are trying to get. If we take 52, the number of total cards in the deck, and divide it by the 4 suits, diamonds, hearts, clubs, and spades, we get the number 13. That means that there are 13 of each of those 4 suits. The number 13 then is the number I want to put on the top of my fraction because there are a total of 13 hearts. If I now reduce this fraction 13 over 52, I will have my answer. Reducing fractions involves dividing the top number of a fraction and the bottom number of the fraction by the same factor, and we want to have whole numbers as a result for both of those divisions. In this case, 13 is a prime number, meaning the only number we can divide 13 by, other than 1, which won't change anything about it, is 13. So we can divide by 13, divide by 13. Now we do know that, of course, 13 divided by 13 will result in the whole number, which is 1. But will 52 divided by 13 result in a whole number? Let's check our calculator. 52 divided by 13, 4. So it does. Our final answer here is the reduced form of this fraction, which is 1/4, which is answer choice C. A group of shoppers at the pet store were surveyed about which type of pet they are intending to buy. The bar graph shows the results. According to this survey, how many more male cats are bought than female fish? Okay, so once again, another question that is not specifically geometry related. Okay, so let's get a good idea here of the number of male cats first. Looking at cats, male right here, probably a little bit less than halfway, I would say 12. Okay, now for female fish, we've got female is exactly at 10. 12 minus 10 is, of course, 2. The distance around the circular badge is 1.5 pi inches. What is the longest distance from each end of the badge? So this is a geometry question, and it's describing the shape as circular, so that means we are working with a circle. It is talking about the distance around a circle, not the area within the inside of it. So what they're referring to here would be kind of like the perimeter of the circle. And it tells us what that distance is. And they describe that distance around the outside of the circle as 1.5 pi. Now, it's interesting here, they're using a little bit of an algebra language when they say 1.5 pi, because pi is a value that we do know. If we scroll down from the top, right here, it's not super clear, but it is on here. They tell us the pi symbol, or the measurement of pi, is approximately equal to 3.14. 1.5 pi, right when they're right next to each other, in an algebra language indicates multiplication. So the distance around this circle is a measurement of 1.5 times pi. Now, what we're going to do is we're going to look at the formula sheet and try to find the appropriate formula that measures the distance around a circle shape. As I mentioned before, the distance around the outside of a circle shape is kind of like a perimeter measurement. So I'm going to go up to perimeter, and there I will find the perimeter of a circle. Now, of course, something that you will notice when you study geometry is that circles have their own vocabulary. Geometry itself has its own vocabulary, but circles have its own vocabulary within the geometry vocabulary. So instead of calling the perimeter of a circle, they're going to use this special word called circumference, but it's basically the perimeter of a circle. They give us two options now, though, for calculating circumference. We can either say that the circumference is equal to 2 times that pi measurement times r, or we could calculate that the circumference measurement is equal to the pi number times d. Well, the letters r and d are abbreviating the two types of measurements that you will see with circles. Every circle has a center point, and r is an abbreviation for the radius measurement from the middle of the circle to its edge. And the radius remains constant all the way around, never changing. The letter D represents the diameter measurement, which goes from edge to edge through the middle. It's almost like the diameter is built from two radiuses that are back to back. And in fact, it does take two radiuses to make one diameter. Okay, so we know now that we're dealing with circumference. We know that we have two options for the circumference measurement using either diameter or radius. But let's take a look now at the actual question again that might shed some light on which form we want to use. It says, what is the longest distance from each end of the badge? To me, that indicates the width of the badge. So that means that using the diameter form of this circumference formula is going to be our best bet. If you're doing this test at a testing center, this is something that you would write on your whiteboard that you have in front of you, your physical whiteboard. If you're taking the GED test from home, then you're going to want to use your mouse to write out what I just did there on the whiteboard, the virtual whiteboard that you're going to be provided with on your GED test from home. The link for that is going to be next to the formula sheet when you're taking your GED test. Just click on that, write the formula in with your mouse. That way you have it as a nice reference. Okay, now that we have our formula, let's once again start putting some of these numbers in that we know. It's a little strange because we actually, instead of calculating the circumference by multiplying those things, we are provided with the circumference and we need to figure out what the diameter is. So we're kind of working in reverse. We're ultimately going to be taking our circumference measurement and dividing it by pi. So rather than multiplying things to get my total circumference, I'm going to take my total circumference and divide it by something to get the other little component of it, in this case, diameter. Okay, so my circumference measurement is 1.5 times pi. Now, at this point in your question, you may have already multiplied, or you may think that we need to multiply 1.5 times pi. If you did that already, that's okay. If you haven't done it already, you actually don't really need to, because check this out. We're going to take our circumference measurement, which is listed as 1.5 times pi, and ultimately divide that by pi. Now, what happens when you have something on the top of the fraction and on the bottom of the fraction that's exactly the same? They cancel out. So what remains then in our fraction is just 1.5 on the left side, and what remains on the right side of the fraction is the letter D. So 1.5 is equal to the letter D, and that answer choice is B. Determine the area of the parallelogram. Hint, use the formula sheet to determine the formulas needed to solve the problem. We are going to try to locate area, and within area, the parallelogram shape, which is what they're showing us here on the screen. So let's hop over to the formula sheet. Okay, on the formula sheet, we want to locate area, which is right here. And under area, let's locate parallelogram. Now it says to do BH, B times H, if we think in terms of algebra language. B stands for the word base. H stands for the word height. So we just determined that we need to multiply base times height in order to calculate the area of the parallelogram. Base is a nice word that's pretty descriptive, because if you think of the base of some object, that typically what comes to mind is whatever is on the bottom. Also, height is a nice descriptive word too. Height is describing from the base to the tallest point of that object. When you're comparing the measurement of height to the measurement of the base side of it, that should form a nice 90-degree angle. On a question like this, then, we do need to be careful that we're using the appropriate measurement for height, which is the tallest point of the shape straight down to the base, forming a 90-degree angle. That would be the number 4, with this little box here, this little square indicating 90 degrees. So 4 is my height measurement. Now, what is my base measurement? 3 does not describe the full distance. It just describes the corner to that point where the height touches the base. One of the properties of a parallelogram is that the distance of the base on the bottom part of the shape is the same as the distance on the top part of the shape. So where they've labeled 20 on the top is also the distance from corner to corner along the bottom. So 20 is ultimately our base. And then multiplying 20 times 4 gives us a measurement of 80, and that is our answer to this question. The area of the rectangle is 40 1/4 square centimeters. Determine the length of the unknown side. The total area of this shape involves taking the measurement of this side, which is just 7, and timesing it by the side which forms a 90-degree angle with it, which is this side here labeled S. We don't know this side measurement, but if we were to multiply those two things together, 7 times S, it would equal the area. Now they do give us the area measurement in total, which is 40 1/4. Let's take a moment and change that 1/4 into a decimal. So to do that, I'm just going to pull up my calculator and type 1 divided by 4, the top number divided by the bottom number in that order, hit enter, and I get 0.25. If I add that to my 40, I get 40.25. So the total area of this rectangle is 40.25. Now, similar to the question we saw earlier with when the whole circumference of a circle was given to us and we had to figure out the smaller component, the diameter, this is similar, where we are provided with the entire area and we need to figure out the measurement of one of its components, this side. So rather than multiplying to get the total area, we're going to take the total area and divide by the smaller component that we do know, which is this 7. Conveniently, I already have 40.25 in my calculator. I'm just going to leave it there and hit divide by 7. And there we have the measurement of that missing side S. Now, this is a little interesting because when we look at our multiple choices, none of them have a decimal in it. They all have this mixed number. But we do have enough information in this case to choose the correct answer because 5.75 means that the whole number part of the answer has to be 5. And out of all of these, the only whole number with 5 is choice B. Determine the surface area. Hint, use the formula sheet to determine the formulas needed to solve the problem. All right, in our picture here, we can see that we have a three-dimensional object, which is like a long box. And indeed, surface area is always referencing some kind of three-dimensional object. Area itself is flat, yes, but surface area then is referring to all of the flat surfaces added together when looking at a three-dimensional object. So with this shape here, I'm going to try to imagine for a moment what this would look like if I was to be able to pick it up and kind of turn it around and things like that. That makes a total of 6 surfaces. And with this being the shape of a box, the opposite surfaces, whether top, bottom, left, right, front, back, the opposite surfaces are the exact same size. They're the same area. The goal for this question then is to calculate those areas and then add them all together to get the total surface area. 4 times 15 is 60, and because this same rectangular shape repeats on the front and the back, I've listed 60 2 times. 3 times 4, 12. Repeat it again on the left side. The top and bottom involve multiplying 15 and 3. Now that we have all of our area measurements, we're going to add them together. Equals 234, so our answer choice is D. The length of the missing side is between what 2 integers? Then they give us the shape of a triangle that has a right angle in it. As I mentioned at the beginning of the video when I was reviewing the formula sheet, there's one formula that's tucked away under the algebra section that is used specifically in a scenario like this, where we have a triangle with a right angle in it. 2 of the side lengths are provided and the third side length is missing, called the Pythagorean theorem. Let's head to the formula sheet again to take another look at that. Okay, so scrolling down, we find that formula here. And it is listed on the formula sheet as a to the second power plus b to the second power equals c to the second power. The letters A and B are referencing the 2 shorter sides creating the 90-degree angle. The letter C is referencing that third longest side. The 7 feet and 5 feet measurements in the diagram are referencing the 2 shorter sides because those are the sides that create the 90-degree angle. Now you could approach this formula as if you were solving an equation in algebra. However, I have a recommendation for how to solve this, which basically breaks down to 3 steps. The first step involves taking each side individually and squaring it. The second step is to take those 2 answers and either add them together or subtract them. You would be adding them together if you're trying to find the longer side. You'd be subtracting them if your missing side was one of the shorter sides. Third is to take whatever that outcome is and do the opposite of squaring a number, which is called square root. The opposite of an exponent in general is a root. So we're going to be doing the opposite of taking it to the second power by doing the second root or square root. So let's see how that plays out, those 3 steps. First, we're going to take each of those side lengths and square them. 7 times 7 is 49. 5 times 5 is 25. Second step, since we're locating the third and longest side, we are going to be doing 49 plus 25, which comes out to be 74. Now, the third and final step is then to do the opposite of second power, which is the second root or square root of 74. So you can almost imagine those original sides being 7 and 5. We took those numbers and we squared both of them, getting these humongous numbers, 49 and 25. Then we do something with those big numbers. In this case, we added them. Now we need to take that result, 74, and bring it back down to the world of regular sized numbers. Square root means what number times itself equals 74. However, there's no whole number that we can multiply by itself to get 74 as an answer. That explains the instructions for this question. It's not asking us to actually calculate the exact answer. Rather, it's saying what two numbers does this answer fall between, where those two numbers are whole numbers, what they're calling integers. So what two whole numbers does this fall between? Well, if we don't have a calculator, we can approach it like this. I'm going to start with my biggest numbers, which is answer choice D. And I'm going to take 8 and I'm going to square it, meaning times it by itself, which is 64. So 8 is really just the square root of 64. You could think of it like that. It's kind of strange, but the square root of 64 is equal to 8. Similarly with 9, 9 times 9 is 81. And so 9 is really just the square root of 81. Now check this out. The square root of 74, does that fit in between these two? Yes, it does, because the number 74 is in between 64 and 81. So that means our answer is D. The Pyramid of Giza in Egypt has a square base. A model of the pyramid is 5 feet on a side and 4 feet high. What is the volume of the model? When it comes to three-dimensional objects, the measurements we're going to be asked to do on the GED test will be in this area right here, surface area and volume. There are two basic types of three-dimensional objects. One of them is a prism. They're actually including the word prism in a few of these, but I'm going to highlight all the prism types. The other type of three-dimensional object is a pyramid, which they have listed as pyramid and also as cone. Prism is a type of three-dimensional object where you have the same shape on the bottom and the top connected by lines. A cylinder is just a prism that has a circular base, whereas a rectangle prism is a prism that has a rectangle base, like a cardboard box. For all prisms, what you need to do is get the area of that base surface, whatever it is, whether it's a circle or a rectangle or a triangle, get the area of that shape and then times it, that area, times it by how tall the shape is or the height of the shape, and you'll have your volume. A pyramid shape, by contrast, has a shape on the base, but it goes up to a single point, like you might imagine in your mind when you picture the pyramids of Egypt. What you're going to do is get the area of the base shape of the pyramid, whatever that is, times it by how tall it is, which is the tallest point straight down to the base, forming a 90-degree angle. Now, so far, those two steps are the exact same as the prism. In fact, with a prism, that's where you stop. For a pyramid, there's one extra step, though. We get the area of the base shape, times it by how tall it is, then we have one more step of dividing that answer by 3. On the formula sheet, they use fractions to show that, rather than saying divided by 3. We know now that we're dealing with a pyramid, and we know that our general process is to multiply the area of the base times how tall it is, and then divide by 3. The shape of this pyramid's base is a square. It tells us that in the instructions. A square, we know from prior experience, is where all sides are the same length. It also has 4 sides, of course. So a 4-sided shape for area means we multiply the base, we multiply the 2 sides, which form a 90-degree angle, basically like the base and the height. So it's going to be 5 times 5. That means the area of the base is 25. 5 times 5 is 25. Then we're going to times that by how tall it is, which is 4. Then we're going to take that answer and divide it by 3. 25 times 4 is equal to 100, divided by 3, and we get 33.3 repeating. Now that does not match any of the answers provided in the multiple choices. So let's step back and try this again. Maybe we have to stop somewhere before we actually do the final division. Let's do 25 times 4 again, and we get 100. Now instead of dividing by 3, let's just write it as a fraction, 100. Instead of actually doing the division divided by 3, let's just leave it as a fraction where 3 is on the bottom, because that really means just 100 divided by 3. And now we can see clearly that our answer choice is B. What is the range of the frequency table? Okay, if you know what range is referring to, this could be a 10-second question. Range is often used along with the other data analysis terms like mean, median, and mode. But it's measuring something much different than mean, median, and mode would measure. Basically, range is measuring how far spread out are the numbers. And to make that calculation, you need two numbers of the data set. You need to know what the largest number is, and you need to know what the smallest number is. And then you subtract those numbers, and you have your range. So with this frequency table, we can see that there's an X above the number 10, which means that one of the numbers in the data set is 10. And there's two X's above the number 4, meaning two of the numbers in the data set are 4. It doesn't change the fact that 10 is the biggest number and 4 is the smallest number. So the range would be 10 minus 4, 6. Michaela is making her 4-digit bank account PIN. If the PIN can only be numbers on a traditional keypad and the numbers cannot be repeated, how many total PINs are possible? Now, they have given us some good information in this question. I think I have a good idea of what they're going for, but they did leave out an important piece of information. What they didn't tell us is whether the PIN 1, 2, 3, 4 is that considered the same set of numbers or a different PIN altogether. I bring up that detail because if the order matters, then the process to answering the question is simpler than if the order didn't matter. So I'm going to first answer this question like I believe they want us to, where the order of these numbers matter. Now let's get to it. We have to ask ourselves two questions. First, how many decisions do we have to make? And second, how many options do we have for each decision? So we have a 4-digit PIN code. That means we have to make 4 decisions for the digits that we're going to be using in our PIN. Now I'm going to make 4 little boxes to indicate 4 decisions. That's the first thing we ask ourselves. The second thing is how many options do we have for each decision? For the first number that I choose in my PIN number, I can choose from the digits 0 to 9, which is actually a total of 10 options. 1 through 9 is 9 options, plus the digit 0 is a 10th option. So for that first digit of my PIN, I have 10 options to choose from. For the second digit, however, I only have 9 options because I can't repeat whatever digit I just chose before. And it goes down to 8 options for the third number, and it goes down to 7 options for the fourth and final number of the PIN. Now, once you have that information in front of you, the 10, 9, 8, and 7, all we have to do is just multiply those numbers to get the final answer here. 10 times 9 times 8 times 7 is equal to 5,040. So I'm going to go ahead and choose that because I believe that's what they mean for us to do, and it is. All right. Well, thank you so much for your attention with this set of 10 questions. I hope that was helpful for you, and I'll see you in the next video.